Hi guys, you are welcome back to my YouTube channel. Today I'll be showing you how you can design and detail a cantilever retaining wall with ProtaDetails. Okay, so let's get into it right away. Let's create a new project and then I will name it as retaining wall. Okay, then choose a design template. I'll pick BS8110, then import. Okay, so we just start by creating a new drawing. I don't need any template for now. Okay, so this is the interface of ProtaDetails. Actually, ProtaDetails is for detailing of reinforced concrete. However, its usefulness does not end with that. You can actually design in ProtaDetails. There are some library, the design library and the detail library, where you have some designs that you can actually do there instead of running it in ProtaStructure. Okay, so and one of it is retaining wall. So we'll be dealing with retaining wall for today, which is cantilever retaining wall. All right, so to do that, just come to design library and then you pick this one, which is cantilever retaining wall. Okay, so when you do this, at the top you see about 7 tabs. You see the geometry, the soil parameters, analysis, setting, total failure, design, and then drawing and report. Okay, so you deal with this one by one. All right, so the first one is geometry, which is the essential part. You have to get the geometry of whatsoever you want to draw. Okay, so here is you can see these are the parameters you need to fill in, and this is the diagram. So the diagram will help you to analyze whatsoever you are drawing. Okay, but for today I will be designing a retaining wall that has a total height of 3 meters and then a total length of 20 meters. Okay, so let's fill the wall height. You can see the wall height, that is from the bottom here up to the point here. Okay, so I will fill that to be 3000. Okay, just click on no. Okay, so that's 3000. Then the height, the wall length, I will fix that to 20,000. Okay, then the next one is stem top width. A retaining wall actually comprises of a stem and a base. Okay, the stem is the vertical wall you are seeing here, while the base is the horizontal plate you are seeing. Okay, so it says the stem top width, that is the width of the stem at the top. Okay, so if you want your stem to have the same width at the top and the same width at the bottom, that means your A has to be equal to your B2. Okay, but if your stem is thinner at the top and then wider at the bottom, that means your A will be different from B2. Okay, so if you look at this diagram, you see that your A is thin at the top and then B2 is big, but I want to have the same thickness, so I'll make my A, which is the top, to be 300 and then the B2 to be 300 as well, so they will have equal width. Okay, so you can see that. Then another one you have is the eccentricity from left. You can see the eccentricity, that is, you see that your the stem is actually moving towards this side. So your E, the eccentricity from the left is 200, but I want the stem to be straight, to be vertically straight, so I will change the eccentricity to 0. Okay, so that will give me a straight wall. You can see the wall is now straight. Okay, then the stem bottom, which is B2, we've changed that before. Then the back plate, I haven't let's deal with this one, the base plate from the left. This one, let's change it to 450. The back length, I want the O length to be 2.5 meter. So what I'll just do is I will say 2.5 meter minus B2. You know, back length is B3, but I want the O length to be 2.5. So I'll just say 2.5 minus B2 minus B1, right? So that'll be 2.5 minus 300 minus 450. Okay, so that will make this my back length to be 1750. Okay, then the base plate slope angle, you can just leave this as at 0. For example, if you put it at 45 degrees, you will see it will just swing it to one side. You see, this is how it will swing it, but this is not what I need, so I'll just put it in 0. Okay, you see this you are seeing here, the shelf and the parapet, they still have to do with the stem. Okay, so let's assume you want to have a shelf, a single shelf, for example. Just click on this. They are going to see you have a shelf like this. You know, you may have a retaining wall, then at the top of the retaining wall, may be connected to another slab. Okay, so let's say that's what you have. Let me just pick this one, the ys. You know, you can see ys, that's the distance from here to here. So I'll just make the ys to be 0. So that will make it to flush to the top here. You can see it will flush to the top over there. Then the bs, which is the length, let me assume the length is 1.5. Okay, you see it goes outside more. Okay, and then the thickness, which is ts, 300 is enough. You know, at times you may want to have a cantilever. Okay, so you may need a wall, then have a slab, then at the top of this shelf you now have maybe a parapet wall. Okay, so and then you may have a parapet wall here. So if you need a parapet wall, this is where you click on. So what about if you need 2 shelves instead of 1 shelf? You have to click here. Okay, so you see there's another shelf here. Okay, so you can always work with the, you know, with the distance. Let's say the ys2, let's say that one is 1.5. You will see where it will place it now. You can see this is where it will place it. So depending on the number of shelves, but you can't go more than 2 shelves actually. So that is how you work with that. Then if I want to eliminate it, just click on it back. Click on this back. Then it will eliminate the shelf. If you need it back, if you don't need this shelf anymore, you have to click on this again, but I actually need the shelf, so I will leave it as that. Okay, then for the parapet, you need a parapet is simply a wall you have on the wall, you know, like a parapet wall. Okay, then you click on it, then you see it will bring a wall there. Then you can also, you know, change the dimension and everything, but I don't need it, so I'll click it again. All right, so that is all for the stem. Then we go to the base. Let's deal with the geometry of the base. So to do that, you come here. There are 3 types of base. You can see number 1 is this one, where you see at this side you have about two height in this. From here to here is different from here. You can see this side is higher than this side. So this is one kind of base you have. You can have another one is when you have a straight base. You know, this one, let's click on this one. You see you have a straight base like that, but for this one, this is what you have. Okay, so that's 2. Then the third one is when you have a shear key. Okay, you know, a shear key is what you call toe beam or what you call heel beam. Okay, so when you click on this, let me click on this one first. That is, I have a straight base, then I have a shear key that you can see. All right, you can see that. So let's try to adjust the dimension of the shear key. Let me say the height of the heel beam is 600. Okay, then the width is 300. Then ek, that is the distance from here to here. The distance, I think that should be 2.5. Let me use 2.5. Okay, then kk is simply the distance from here to here, but I don't need what's it called, I don't need this kind of chamfer, so I will just put it at 0. Okay, put it at 0. Then this is what I'll have. This has changed back to 2000, so I'll just put it in 2. Okay, so, and that's it. You can see, so I have a shear key here, but no, my shear key shouldn't be around here. I need a shear key at this side, since my back fill will be here. So I need a shear key at this side, not at this side. This is a wrong orientation. So I will make the ek to be equals to 0, then 0. So that will transfer it to this side. Okay, so this is the proper position for the heel beam, since this is my back fill. Okay, so that this will be coming like this, and then this will be coming like this. Okay, so that is one. But you can also, you know what I just did is I picked the combination of this straight base plate and a shear key. You can also pick the combination of this one and this one, you know, when you have something like this. All right, but I want to pick this. Okay, so you also have to decide what is the thickness of the base plate. So I'll be using 300 for the thickness of the base plate. So 300. Okay, so this is all for the this is all for the geometry. So I have fixed the geometry. All right, so when you are done with the geometry, you go to the soil parameters tab. Okay, so you come to the soil parameters tab. Actually, you have three kind of soil. One, you can have a front fill, you can have a back fill, and you can have a ground soil. You know, front fill is the soil you have at this side. Okay, then back fill is the soil you have at this side. Then ground soil is basically the soil at the bottom of the base. All right. Okay, so this side is just about the property of the soil. So let's say I have a sand. Okay, my sand is sandy, that is, it is a non-clay. Okay, so the angle of friction, the frictional angle, I'll just use 30 degrees. Okay, but if you are using a clay, you can put the angle of friction to be 0. That will tell you that this is a cohesive soil. All right, from the front view, that is the soil that will be at the front view, I will use 30 degrees, 30 degrees, 30 degrees for everything. Okay, then the wall friction, I'll put 0. Then the dry unit weight of sand, it is 18 actually. Okay, so you don't need to change this, that is default. Then the saturated unit weight of sand is also 20, so you don't need to change it. Okay, then the cohesion is 0, 0, 0. Okay, so that is good enough. Then you can leave this as default. These are actually defaults, okay, for sand. But if it is clay, then you have to, you know, just check your books and then put in the right value. Okay, now let's deal with the way it is being filled. Now, this retaining wall, you know, a retaining wall can actually be retaining the water and it can be retaining the soil. So you have to know which of them you are doing. Okay, so what I want to do right now is that I am actually retaining a soil, not a water. Okay, and then so let's go about it. Now you can see, look at this, it says soil fill height. That is, what is the height of which I have filled the soil. Look at it, front view. So if you look at this side, HP, this is the height of soil at the front. And when you look at this side, you can see this side, this is where you fill the soil. This is to the brim, you can see 3000. Okay, so I will just say I didn't fill it at all at the front, so I'll put this to be 0. There's no fill at all at the front, so 0. You see this has gotten eliminated. Okay, you see there's no more soil at the front, you only have soil at the back. Okay, so this one, it is being filled to the brim, but let me say it is filled up to 2.5 meter. Then you see this will reduce, that's reduced. Okay, so that is good enough. Then height of water table. Okay, so I will assume that, okay, at this side the water table is 0. Let me say the water table here is 500. You will see that water is at the top here. Okay, so this is where the water table is. Okay, so let me just say, but I will say it is 0. I don't need, there's no water there, there's no water table. Okay, so at this other side too, which is the back fill, I will still say the water table is 0. You can see the height at which the water is, which is 2.5. It is on the same level with the point where there is soil. You can see 2.5. So I will say the water table is not there, the water table is 0. So there's no water, it is only backfilling soil, that is dry soil. There's no water in the soil. All right, so you can see this is now where I have the water table. You can see the sign of water. You can see this is where it is. So this is where I have my water table, and this is basically the soil. Okay, then I have a surcharge. If you don't need a surcharge, you know, surcharge simply means the load that is being placed on the soil that is used as backfill. You know, the backfill is a load on the wall, which is the retaining wall. But there's still a surcharge, that is the load of people, the load of other equipment, you know, dead load and live load. Just compute everything into a UDL, then you now place it on the soil. That will now be called surcharge, right? So if you have a surcharge, which is more practical, it is more practical to have a surcharge. So you can just analyze the value of the surcharge and put it. But even though you are seeing at the front view, you are seeing 3 kilonewton per meter square. You see there is no soil at all, but there is surcharge. But this you have to put 0. If you don't have a soil, then why are we having a surcharge? Okay, then for the backfill, you can do some computations, but if you don't need a surcharge, you just need to put down 0, then this will get eliminated. You can see there's no surcharge. Okay, but it's more practical to put a surcharge, so I'll just put the value that was there before, and then I'll put the width to be 1000 and then the length to be 1000. All right, so I think this is good enough. Okay, so that is one. Also, you have to talk about the ground soil. You know, we've talked about the front view, we've talked about the back fill. So you also have to talk about the ground floor, the ground soil. So this has to do with the ground soil. Okay, so first of all is the soil bearing capacity. Okay, so the soil bearing capacity, it is 200, but I will change this to 150. Let's assume I'm using 150. Then the minimum allowed soil bearing capacity, which is minimum allowed SBC, I'll just leave it as 1. Then the base friction of friction, let me use 0.45. That is the friction between the ground soil and the base of the retaining wall. Okay, and then the adhesion, put it at 10. Okay, then you can do some analysis setting. You can come here. So we are done with this side. You can come to analysis setting. So and then you can see here you have your seismic zone. For the seismic zone, there are about 4 zones. You know, 4 to 4 zone. The 4th zone. Okay, yeah, you can see there. So depending on the kind of seismic load you have to know which zone it is depending on. Okay. So I'll just pick the 4th zone, and then your safety factors. You know, a retaining wall can have about 3 limit states. You have the sliding, you have overturning, and you can have shear, right? So you have to know the safety factors for each of these limit states depending on the code you are using. Okay, so I'll just leave this as it is, but if you want to, you know, you can just want to adjust this for the static and dynamic, so just work with it. Okay, and then all of these, whatever I want to include, whatever I want to remove, but I'll just pick the default. Okay, so and that will lead me to design. Just go to the design. So under the design, this is basically the important part. You will see what you have here. You have some. So what you just need to do here is you come to your concrete. You know, what do you want to use for your concrete? I want to use C25/C30. Then you click on OK. And then the rebar 410 is good for the grid. I just need to change the dimension. So select and select all. So I'll pick 12 mm. Then I'll pick 16 mm. Then OK. Then for the length, so I will pick 8 mm and then 10 mm. So 8 mm and then 10 mm. Okay, then you click on OK. So that is basically everything on the design tab. But before you design, you can come to drawing and reports. Okay, so under the drawing and reports, basically what you need to pay attention to is the scale of the drawing. Okay, so you can see this is 1:25. And then the other thing you have to pay attention to is the drainage details. You know, when you have a retaining wall, you have to know how you have to drain it. Okay, even though the water table is below the base of the wall, you know, there will still be rainfall. There will still be probably rainfall and then water draining from other places to the retaining wall. So the soil that is used for the backfill will actually absorb water, and when this water stays, it can affect your retaining wall. So you have to think of how you have to drain the water. Okay, so you can drain the water with a whip hole. A whip hole is basically, there will be a hole that leads from, you know, this is your retaining wall, right? So there will be a hole that leads from here to here. So the water inside the backfill can actually get drained through that whip hole and then escape at the front. So it will now escape through the front. Okay, so if you want to use a whip hole, you have to click on whip hole, but if you don't need it, you will escape. So I need a whip hole, just click on whip hole. Then how large do you want the whip hole to be? What is the diameter you need for it? Okay, so let's use 100 mm. Then at what spacing would you want to have that whip hole? 1.5 meter is not bad, so I'll just leave it like that. Okay, so that is how you drain water in this direction. What about draining water in this other direction? I mean the direction that is facing me. Okay, so you can use a drainage pipe in that kind of sense. Okay, so the diameter of that drainage size of that drainage pipe, you can use 200 mm. So that is the default, but you can change it. You know, I don't want to change that, but I'm just trying to explain why it is there. So you go back to the design tab and then you click on redesign. Okay, so you see that all of this has changed. Before it was 10 mm or whatever that was there. Okay, but has now changed based on the kind of diameter I chose. You know, for the actual stuff I chose 12 mm and 16 mm. So you see everything is actually 12 mm. Okay, and then the chair bar, we don't even need chair bar. You can see the chair bar, just take it with the chair bar. And then this one, this is a link. You can see share key distribution rebar. Okay, this is distribution bar. Okay, if it is a distribution bar, then let me just pick 12 mm. No, 12 mm. What about this? This is also a distribution bar. Let me pick 12 mm. Then tie bar, there's nothing like 9 mm. You can change it to 10 mm. Okay, then just check your design. No, it has actually designed it, and you can see the spacing behind it. Okay, so these ones that you have 140 mm spacing, maybe if you are not contented with that, maybe you feel that can be achievable, you can change it to 125. You know, okay, but you can't change it to 150. but 125 you can change to 100. That is more better. So whenever you click on a particular rebar, it will show you what the rebar is on the diagram here. Okay, so in case you're having difficulty in identifying what rebar is it, it will show you. For example, you can see stem back face vertical rebar. Maybe you've been thinking, what is that? Okay, so this is the rebar it is talking about. Okay, and here you have about 144 quantities of it. You can see it here. Okay, so you can see the AS required and then the AS provided. So the AS provided is 807.84 and then this is the required. Okay, so you can check that. You can see this is the diameter, this is the spacing. So that is basically all of this. So just click on then you see. So it has actually designed that. Then how do you now see the detail? Maybe you want to prepare the drawing, just come here and click on prepare drawing and then you click anywhere to place it, then just click maybe here. So you can now see the detail. So this is the detail. So you can see this is a whip hole. You can see this is the whip hole. It is 100 mm diameter, and then you can see the spacing is 1.5 meter center to center. And then this is the other drainage in the second side. We have two drainage systems, one in this direction and the other one in this direction facing me. So we use drainage pipe and we use whip hole for this. Whip hole is basically you are drilling a hole. You just put a pipe inside to drill a hole while you are casting. So that is a natural pipe. Okay, then this one is like an artificial pipe. All right, you have to be careful with this pipe. All right, probably you'll be using a steel pipe, so that because if it is a rubber pipe, it can it can crush, it can destroy due to the weight of the backfill. But you just have to know how you do about this. So this is the basic thing. And then you can see the rebar, you can see Y12. So you have 9 numbers, and then you know how to read details, right? So that is basically everything on the retaining wall. If you like this video, don't hesitate to like and subscribe to my YouTube channel. It is very important to me. Thanks for watching.